Hello and welcome back to another video. In this video we're going to look at how should a program respond to errors. So when something goes wrong in your program, should it crash, should it silently ignore the error, things like that. Alright, so there are a few things to consider here. First of all, we're going to talk about what we mean by errors for the sake of this video. Second, we'll talk about the different ways that your program can respond, such as crashing, ignoring the error. Next, we look at a couple of examples of well-known cases and well-known programs and what they do. And finally, we'll talk about what you should consider when deciding which way to go about it in your code. All right, so firstly, in this video, when we talk about error, we mean something like a bug. We mean something that has genuinely gone wrong in your program, okay? We don't mean something like something that's not a bug. For example, would be you have a form that the user fills in and the user just fills in invalid information. Yeah, and your program can't continue until that's fixed. So that's not a bug. We mean something that has genuinely gone wrong and it's your fault, right? Something's wrong with your code. Okay, so there are different ways for how a program can respond in these circumstances. One way is for the program to crash, right? Stop the program execution. Another way is to silently ignore the error and continue the program execution. And finally, the last way is to do something to handle the error so that the program can continue executing as though the error never happened. So in general, crashing the program is a good default. Okay, if you're not sure which way to go about it, crashing the program tends to be a pretty good solution. And that's for a couple of reasons. One benefit of it is that the program won't be doing the wrong thing, right? If the program isn't executing anymore, it won't do the wrong thing. And that's a really good thing because when a program does the wrong thing, that can actually have disastrous consequences, right? It can endanger people's lives and it can lose companies hundreds of millions of dollars. And both of these cases sadly have both happened. So if you crash the program, you avoid that completely. Now, there are of course cases where crashing the program may be a worse option than not crashing it, right? But generally that's not the case. You'll have to consider your own software and what it does here, obviously. But for a simple example, if you have a calculator app, right? And you do something and it crashes, that's not a big deal, right? You can just open the app again, you can retype the calculation and you're good to go. But on the other hand, if you have a calculator app that produces the wrong result, that can have disastrous consequences, right? It may cause you to lose money, it may cause you to... all sorts of things can go wrong, okay? So let's just leave it at that. Another benefit of crashing is that it makes errors immediately obvious. If the program crashes, you know you have an error, and then you can go fix your code right away. Okay, so that's enough about crashing. Another option is to just silently ignore the error. And we'll look at it a bit later, but there are valid cases where that would actually be the best option. And finally, another option is to try to recover from the error so that it's as though the error never happened in the first place and the program can continue executing. Now that tends to be the most difficult option. And in fact, defensive programming, which we'll have another video on, that's what it focuses on. And we'll examine that a little bit more later. But for now, let's continue on to some examples of what some programs already do and some common use cases you might have. All right, so as the first example, consider that you're coding a program, it's in early development, and there is an error. What should you do? You might not have implemented error handling yet, so the program is just going to crash, right? And that's actually a pretty good thing, because as we said, if the program crashes, you know straight away that there is a problem and you can go on to fix it right away. Another example is most desktop applications that you probably know of. So for example, at least in my experience, something like Microsoft Word or Adobe whatever program, if there is a major error, it will just crash. And that's not generally a big deal, right? You just open the program again and you continue. Now, a nice thing about this program is that you don't tend to lose a lot of data because they have autosave features, right? It autosaves every 5 minutes and you're good to go. You haven't really lost a lot of your work. So it's a nice simple solution, right? The developer doesn't have to do too much to make the program recover from an error, and it's not too difficult for the user to just open the program again and continue their work. Next, consider something like Next, consider something like adding to cart, right? So you have a website, you have an e-commerce website, the user goes on a product, clicks add to cart, but it doesn't work. What should the program do? Well, consider the user experience here. It would be an awful user experience if the user doesn't realize that they haven't added the product to cart. And it can happen, right? They might order 100 products. If they're a big company, they order, it arrives a few days later, they don't get the product at all. And they're like, what happened? Anyway, it's a realistic scenario that can definitely happen, and it would be a terrible user experience. So in this case, it might be good to just notify the user, right? Tell you don't have to crash the program, don't silently ignore the error, but notify the user, pop up a message saying, hey, I know you clicked add to cart, but it wasn't actually added. Please try again later, or please refresh the browser and then try again. All kinds of things, right? Something like that. The next example is a simple animation. You have an animation on the website that's not important by any means. It's a very simple visual animation only. And it fails to trigger, okay? So in this case, what should the program do? Well, since the animation isn't important, right, consider the user experience again, you probably don't want to distract the user from the important thing they're doing right now, right, like browsing your products. You don't want to distract them and tell them, hey, the animation didn't work, please refresh. No. That would be really bad for the user experience. The user doesn't want that. Your company doesn't want that because their user is doing something that's going to make you money, okay? So this is a case where the most appropriate thing would be to just silently ignore the error. Don't tell the user, don't crash, don't try to recover. If it's not worth the programming effort, just ignore it, okay? And another example is a single player video game, right? An offline video game that you play single player. Here, let's just say that generally it's considered an extremely bad user experience for a game to crash, but it's considered acceptable for a game to have bugs. Not great, but acceptable, and definitely much better than the game crashing. So again, another case here where you would want to silently ignore the bug, don't tell the user, and don't crash, okay? Something like that. Finally, consider something like an important system in an airplane, or anything that's critical, right? That can have large consequences if it's handled incorrectly. So this is probably a case where you can't crash, and you also probably can't silently ignore the error, because if the program is doing the wrong thing, that can be a disaster, okay? So again, here this is what defensive programming is about, but basically you would have to do everything in your power to recover from an error in this scenario. And there are many things you might do, right? So as a few examples here, you might have a backup system or something so that if something goes wrong, another system can pick up the slack, right? Or you might have a live monitoring program that monitors different parts of your system or whatever. And again, if it notices that something has gone wrong, it restarts it in the background, right? Maybe it's okay if it's off for a second or two. It restarts it and the program's fine. And a lot of other things, but the point is, yeah, you'll do something to recover if that's what you must do. Okay, so those were a few examples, but what should you do in your program? What do you have to consider in your program for which of the options you should take? Okay, so I think the main things you need to consider are, first of all, whether the bug is recoverable or not. Because if you can't recover from it, no matter what you do, well, that rules out that option, okay? Another thing is the user experience, which we saw in a few of the examples. And finally, the effort and the development time it would take for you to apply the different options, okay? Because that can be very important as well. So the first thing, is the bug recoverable without crashing? So some bugs you just can't recover from, right? For example, if some important code in your program just isn't working, there's nothing really you can do about it. Your program is always going to do the wrong thing, and that won't be acceptable. Your only solution is to fix the code, basically. That's it. But some bugs may be okay. And some examples of those bugs are intermittent bugs, things that go wrong in your program, but only once in a while, because, for example, they're race conditions or something. So in this case, you can try things. Like if something goes wrong in your program, you can catch it and you can try to recover from it. Something like this. You can try to run the operation again, right? So as we said, if it's a race condition, it might work the next time you do it. Or you might, if part of your program is faulty, if it's like a sub program, you might restart that particular part of the program in the background or something, right? And then hopefully it will work. Or if an error occurs only under certain circumstances, certain state in your program, you might fix the state and then try again. Or you might call on a server to do the operation instead of the client doing it. There are ways, okay? And as I said, defensive programming is another video you might want to look at for that. Things like that. Yeah. The problem in a lot of these cases, though, is that you may not know ahead of time that your program is going to have this particular bug, so you won't be able to implement measures to recover from it, okay? Because after all, if you knew your program had a bug, you would just fix the code, right? You wouldn't leave the bug in there with a temporary fix. Well, most of the time, and hopefully. So yeah, again, defensive programming for more details on how to handle that exact case. Aside from that, the next thing to consider is the user experience. Okay, so again, we looked at the examples before. In some cases, crashing is acceptable for the user experience. It also tends to be the easy solution, so you might want to go for that. In other cases, you don't need to recover. Like we said for the animation example earlier, don't crash the program. You don't need to recover from that. You can just let the animation not run. It's not a big deal. So you can silently ignore the error. And as we said, in other cases, you have to recover. It depends on your program. And hand in hand with that, consider the effort in implementing those solutions, because that's very important as well. Because in real software, you'll have deadlines. You might not, even if it's a better user experience, you might not be able to make your program recover when it's all right for it to crash, right? Like it's good enough. The user won't be too annoyed, and you just don't have the resources to implement error recovery in that particular scenario. So consider those three things, right? Those are, can you recover, the user experience, and also the effort in implementing the different solutions. One very important thing, though, is that if you silently ignore the error, you should always make sure you record it somewhere, right? Like some error monitoring software or something, so that you know it happened and you can go and debug it later. And we have more information on this on another video. Okay, so that's technically the end of the video, but just before we go, I wanted to leave a side note on how to handle things that aren't bugs in your program. So some example of those would be something like, as we said earlier, the user submits a form with invalid data. That's not a bug, right? You should expect every program to have that problem. And this is not up to your program either. It's completely outside of your program's control what a user submits in a form, okay? So another example is trying to read a file from the file system. Again, like it might not exist. The user might have given you a file path that's invalid. Not your program's fault, not a bug. Now in these cases, the thing is that it's extremely easy to recover from these problems. It's really easy, right? If the user submits invalid data, just pop up a message saying, hey, the email you typed in the email address field is invalid. It should be of this format. Or if your program can't find a file to open in the file system, tell the user, hey, you gave us an invalid file path. Please try a different one. All right. So that's it for the video. We looked at the different ways that a program can behave when it encounters errors. We looked at a couple of examples of well-known cases and well-known programs and how they respond when errors are encountered. And finally, we looked at what you should consider when you're deciding which option to go for. So I hope that this video was useful to you, and if you liked it, then please click the like button. And if you want to see more videos like this, and we'll have a lot of videos coming out on error handling, then please subscribe. And as always, if you have any comments, anything we left out, anything you disagree with, please leave a comment below. All right, thanks very much, and see you next time.